talk about simplifying algebraic expressions. We're starting with some really, this is Algebra 1 stuff, but from seeing your pre-tests and seeing your summer assignment, some of you need an Algebra 1 review. It's been a minute or two since you had Algebra 1. Y'all had Algebra 1 in that building though, right? You didn't walk over here for it. Okay, that's good. Trust me, that's good. Alright, so simplify. On your paragraphs that you wrote, some of you told me that you can't read cursive. I will try to print, but I've been writing in cursive since I was like 9 years old, so it's really hard for me to not write in cursive, okay? And sometimes you'll get like a combination of the two. Like I'll start to print, then I get in a hurry and it turns into cursive, and then I'll try and get back to it. So if there's something you can't read, just tell me. But I'll do my best to print. Alright, so simplifying algebraic expressions. There's two things here, okay, that I want to point out. Simplify and an expression. First of all, let's talk about simplifying versus solving. Solve. That's a V, I promise. Alright, simplify versus solve. Simplify means that you have no more like terms and no more parentheses. Okay? Let's say grouping symbols. Because we're big boys and girls now, and parentheses are not the only thing that we're going to see. So no more grouping symbols. Alright, so that's simplifying. No more like terms, no more grouping symbols. If I give you an expression to simplify, and you give it back to me, and there's still matching terms in there, it's not simplified. Or if you give it back to me and there's still some parentheses in there, it's not simplified. Simplifying means that you have no more like terms, you have no more grouping symbols. That's not like a mathy definition, that's a Harvard definition. Okay? Solving means you're going to get down to a variable equals a number. Okay? That's your goal. Or it could be more than one number. We'll talk about that later. Spoiler alert, it could have more than one answer. Or just different numbers. Alright, here's another biggie. Expressions are simplified. Equations are solved. Expressions are simplified, equations are solved. Does anybody know the difference between an expression and an equation? Yes?
Equation has an equal sign?
Yes, thank you. An equation has an equal sign, okay? If it doesn't have an equal sign, you can't solve it. You can simplify it, but you cannot solve it. And that is something that I saw on your summer assignment. You were told to simplify, and you told me what x equals. That's impossible. If there's not an equal sign and something on the other side of it, you can't figure out what x is. You can only simplify. You cannot solve an expression. If you have expression equals expression, well, now we've got an equation. I can solve that, but just an expression in itself can't be solved. You've got to have an equal sign. Okay, if it's an expression with a variable, you can't solve it. The only thing we can solve are equations. Okay, that's it. You know that thing, it's like, if math taught me anything, it's that every problem has a solution. Not really. Every problem has an answer, but it may not have a solution. Equations have solutions. Expressions are just simplified. So, but I won't judge the silly stuff you see on the internet. Actually, I will. I'll just do it myself. Okay. Any questions about these right here? I'm fixing to move it. Does everybody have it written down? Yes? Okay. So, simplify, no more like terms, no more grouping symbols, expressions are simplified, solving, variable equals a number, and those are reserved for equations. We're going to just look at simplifying today. That's all we're going to do is simplify. It's going to be super easy. Super easy. All right. 2r plus 7 minus 6r plus 4. Alright, we have two sets of like terms here. What are the two sets of like terms?
2R's, 6R's, and 4.
Right, the r's and then the numbers. Does anybody know what a number without a variable is called? Nay and nay. It's a constant. Okay? These are variables because they vary. R can be anything, right? They're variables because they vary. Like one year I was teaching Algebra A in West Memphis. I taught more than 1 year in West Memphis. Anyway, this one particular year I was teaching Algebra A in West Memphis. This one kid, I gave this worksheet like 50 equations to practice. And he got done in like 10 minutes. And he wasn't like sharpest tool in the shed. And I was like, how'd you do that so fast? He said to me, well, on number 1, x is 4. So I just went through all the problems where there was an x and wrote 4. So I figured out that x is 4. I was like, oh, this is gonna be a good year. I said, you know, it's called a variable because it varies. Yes. He got to spend 2 years in the 9th grade. So, anyway, yeah. And I think now he's spending like 10 to 28 coming, so we'll talk about that later. Alright, so here's what I like to do. When you're combining like terms, okay, the sign that's in front of the term goes with it. Right? So this is going to be 2r minus 6r. That minus sign goes with the 6. Okay? And then you're going to have plus 7 plus 4. Alright, so what's 2r minus 6r? Negative 4r. Right. You don't have enough. Your 4r's in the hole. Okay? So what about 7 plus 4? 11. Fantastic. Okay. Can this be simplified any further? Are there any like terms? Are there any parentheses? Can I figure out what r equals? Who said yes? Who said it? Who said yes? I'm going to be after, while you're walking out of class, you're getting whipped with the flip-flop. Okay, there's no equal sign. If there's not an equal sign, I can't solve it. I can't figure out what r is, okay? No equal sign, no solution for this particular problem. That's the answer. That's the answer right there. Circle it, you're done. That's as far as you can go. You cannot figure out what r is because I don't know what it equals. That's your solution. I need to take the passcode off this. It's too long. Alright, we talked about powers also have to match. So if I have 3x squared plus x cubed minus, I don't know, 5x squared minus 7x cubed. Are those all like terms? No, they are not. They are not. Because these are not the same. The variables and their powers have to match, okay? Alright, I'm going to give you like 10 seconds to do that one. Alright, so what's 3x squared getting combined with? Negative 5x squared. Okay, so I've got 3x squared minus 5x squared. What about this plus x cubed? Alright, so 3x squared minus 5x squared leaves me with how many x squared? Negative 2x squared. 2x squared. Don't lose that squared, okay? It's still right there with you. Like if you have 5 puppies and someone takes 2 puppies, you have 3 puppies left. You don't have just 3 of nothing. The puppies don't cancel out, okay? The x squareds don't cancel out. You have 2x, you're actually in the hole, 2x squareds, all right? What's going on right here? How many x cubes is that? That's 1. I don't see a 1. Do you see a 1? No, but it's there. Right there. Like, that's, you don't say 1 puppy. You just, I have a puppy. I mean, you might say 1, but I have a puppy. You don't necessarily put a number in front of it. It counts as 1. Okay? I have 1x cubed. So what's 1x cubed minus 7x cubed? Right. Can I go any further with that problem? Blue shirt. Can I go any further with that problem? No. Okay, very good. Circle it, you're done. I'll get your name by Christmas, I promise. Valentine's Day at the latest. I'll get everyone's name. I can't even remember my own children's name, so do not be offended. If someone gets in trouble, I start with the oldest until someone comes around, and then I'm like, that's you. I knew I'd get you eventually. So, anyway. Alright, let's talk about multiplication just a little bit. Now, we're actually not going to FOIL today. We're just going to do a little bit of distributive property, a little bit of baby distributive property, but I think we do need to review power rules just a little bit, maybe. Distributive property, easy. You just put the multiplication through the parentheses. Like if I have 5 times 2x plus 3y, that 5 gets multiplied times everything in the parentheses, right? So it's going to be 10x plus 15y. Can't go any further, but no more parentheses, no like terms, so I'm golden on this one, right? I'm done right there. That's it. If it has a variable, two m times 3mn plus 4m. Okay, so we multiply the numbers. 2 times 3 is what? 6. What's m times m? M squared, right. And then just stick that n on there. And then 2m times 4m would be what? 8m squared. Can these two be added up? Right, because that n right there. We can't do it because that n. So we're done with this one. There's no like terms. There's no parentheses. Whatever. Right there. Okay. Pretty simple, right? Let's see. I'm just going to give you a problem to do that's like 12 miles long. Not that it's difficult, it's just going to be really time consuming. Sometimes people confuse time consuming with difficult. No, that's not an issue of difficulty, that's just laziness, okay? Difficult and time consuming are not the same thing. So let's say we got 5y 2x plus 3y minus 6z minus 2x times 4y plus 8 plus 3z times 2x plus 1. Alright, there you go. Simplify that. Alright, so I'm going to do some distributive property here. This is going to give me 10xy. That's going to give me 15y squared. And that's going to give me a negative 30yz. Okay? Right here, this is going to turn into a negative 8xy and a negative 16x. It's going to be, what, 6xz and 3z. Now, we did make some like terms here. I think only, what?
Does it matter, like, when you put the 10xy, the variable?
Well, it doesn't matter because multiplication is commutative. So you can do multiplication in whatever order. But we like to look at them in alphabetical order. So we like to put the one that's first in the alphabet first. I think the xy's are the only like terms, aren't they? Let me see. Yeah? Alright, so 10xy's minus 8xy's leave me with how many xy's? 2 xy's. Yes. Alright, any questions about this? Got it? Good. This is just a reminder, right? None of this is new. You just filed it away in your brain and you're having to go through those filing cabinets and find that one, right? Can't remember what you saved it under, so you're having to search all the documents. Yeah, I've been there. I know. Some people are still writing, so I'm not going to move it yet. Your assignment is on Google Classroom. You're going to work on it for a little bit in class. If it's on your phone, if you can get to Google Classroom on your phone, that's fine. Look at it on there. If you can't, if you need to get a computer, you can get a computer. I just brought it up on my phone. It's a PDF. So, but the directions, we're going to talk about that, okay? Because there's like 178 problems. And you only have to do 176 of them. So I'm going to let you know. JK. Alright, so if you will look at the document, it's in the About for your classroom. I'm going to stop recording.